Hello, everybody. Welcome to this live stream program. We're here live at McDonald Observatory, and we are going to show you some planets and talk about planets. But first, I want to start with introductions. I'm Judy Meyer. I live and work here at McDonald Observatory, and I get to work with students and their teachers who visit us and connect with us in other ways. And I also work with the public, people who come and visit the observatory to see the big telescopes and see our beautiful nighttime sky. So co-hosting with me, I have my friend Martinique Pautsky. And Martinique, tell us about yourself.
Hello, I'm Martinique. I also work at the Observatory Visitor Center with the K-12 program, so students, classes that visit, virtual visits, and the public, just teaching about astronomy. Thanks, Judy.
Yeah, we also have moderators in the chat, and they still have their Halloween costumes on. They're going as Supernova and Nebula, and they want to answer your questions. So if you have questions and you're watching this live, put them in the chat. And if they can't answer them, or they don't want to answer them, or they think maybe we should answer them, they'll kick those questions over to us, and otherwise they'll try to answer them in the chat. Later on, you're going to meet Joe Wheelock. He's in a telescope dome driving the telescope that we're going to use tonight. But you have to wait a little while to meet Joe. So we're here at McDonald Observatory, and we're in far west Texas. And what I'd like you to do in the chat right now is put in the chat where you live. And maybe you could put in something else about yourself, like if you're a kid, what grade you're in, or something like that. And I want to show you where we live. So I'm going to share my screen here. Yes. So here we are in Texas, and you can see Texas here, right? Some of you are in Texas, but some of you are other places. Oh my goodness. I am seeing other places like Maryland and Texas and Illinois and New York. And oh my goodness, isn't that something? So I have to figure out how to get to my next slide. Okay, so we're in Texas, and we are far, far in the western side of Texas. So there's a little red circle where we are right now, and we're far from the cities of Texas. We're way out in the country, and that's important for us. And we're gonna take a look at the view from here in a little bit. Now, I want to ask you all another question. Can you think of some reasons why being way out here in West Texas is a good place for an observatory? If you can think of some of those reasons, type that into the chat and we'll see what you come up with. And while you're coming up with reasons, I want to show you a few more pictures of McDonald Observatory. So imagine if we flew into the McDonald Observatory on a helicopter. Flew in on a helicopter. What you might see is a view like this. It's two mountains, and on one side there's two white domes on the mountain. On the other side there's a silver dome. Those are our two mountains where our research telescopes are. And then lower than the research telescopes, kind of in the middle of the picture, is our visitor center. And that's where most folks who come to visit us. They come to the visitor center first, and then we take them on a tour of the research areas, or we look at the nighttime sky from here. Let's look at another picture from McDonald Observatory. Here we've moved our helicopter. We're flying in a helicopter. That's kind of fun. And now we are looking down on the visitor center and up to Mount Locke. And up on Mount Locke, there are the two white domes that are the domes that house our two older research telescopes. So that's our visitor center. Let's keep flying. We're going to fly way out away from the visitor center. And here we have a huge view looking from the other side of Mount Locke. And you can see that there are some houses and there are some domes. We can see the two domes of Mount Locke and the silver dome of the Hobby Eberly telescope in the distance. But there are some things we're not seeing. So I'm going to take a look at what the chat says and what you're saying about why this is a good place for an observatory. And I'm seeing dark skies, elevation, drier. And you know what? You hit the three big things right there. We have a nice dark sky, and you can see not a lot of people live around here. And a dark sky is a really good thing. We also have a high elevation, and being at a high elevation means we're looking through less of the Earth's atmosphere when we look up into space. And then another thing that we have here, you can see in this picture, we have a nice blue sky, and that's because we enjoy lots of clear days, and we also enjoy lots of clear, dark nights. So nice, three good reasons to be here. All right. I think it's time for us to look at a planet. Martinique, take it away and show us a planet.
All right, everyone. So the first planet that we are going to look at tonight is actually too low in the sky to see with the telescope. So what we did is that we took a video of it a few weeks ago when it was still high enough. Right now, if our telescope were to try and look at it, it would be looking at the wall. So can't see a planet through a wall. So if you were to look outside really far in the west, you would see this object setting down below the horizon just after sunset. So if y'all went outside right now, you ran really, really, really quickly, you would see something really, really bright just above the horizon in the west. Any guesses? You know what that planet? Oh, wait, don't look. What's the planet that we're going to look at first? We're going to look at Venus first, sometimes called the evening star or the morning star, because it's often real close to where the sun is. And that is going to be a video that we're going to see first. And I'm going to pull up Joe's video. Joe's going to show us the video of this. There we go. Thank you, Joe. This is that video that we took with our telescopes just a few weeks ago. And I want to make some observations with you all about Venus. I want to know, is this what you thought it would look like? And what do you notice about it? Make some observations. Either tell somebody sitting in the room with you or drop it in the chat if you can. Tell me about some observations that you are noticing about Venus. I'm going to wiggle like Venus is wiggling to give you guys all a chance to type something in there. Tonight we're going to be using one telescope, Lauren, but on site we have over a dozen research telescopes and dozens more telescopes that we use to just show off space to visitors when they come. Ah, it looks like the moon. Yes, it does look like the moon. And a few reasons it looks like the moon, right? It's just kind of white, bright white. And we are going to see all of our objects tonight in black and white because we're using a black and white camera. So we're going to see lots of grays, lots of shades of gray. And Venus is also like the moon because it does have phases, right? It's kind of a half circle there. And Venus has phases just like the moon because of how the sun shines on it. You might notice that it's wiggly. That's because when we look through air, our air wiggles that light around, it refracts. So it looks a little wiggly. And it also might look a little smaller than you thought, and that's because it's far away. When something's really close, it can look really big, but when it's far away, it can look small, even with a telescope. Now we could use our telescope computer, right? The computer program to like make it bigger, to zoom in. But when you zoom in on stuff too much, it starts to get really like pixelated, and that's what would happen. So some things are just best to leave leave smaller the way the camera is kind of best set up for it. But let me talk about phases with y'all. Phases in Venus were noticed back in 1610 when Galileo pointed his little telescope up at Venus. He noticed the phases, and Galileo started making little sketches and determined that if Venus has phases, it must be orbiting around the sun closer than the other planets. It was kind of one of the first reasons that we really believed that we weren't the center of the universe on Earth. It was the sun that might be the center that we're all going around. Now, I do have a little bit of an example to try and show you some phases. To do that, I'm going to make myself really big here. Sorry, Judy. There we go. I have a pretend sun here and a pretend Venus. And I'm going to make it a little dark in here. There we go. And I recommend y'all try this a little bit later, because a lot of times when people are learning about phases and the moon, it's kind of fun to practice with Oreos. But when you're learning about phases with Oreos, like you twist them apart and you see a circle, and like you take a bite and then it's a crescent. That's like delicious. Don't get me wrong. That's how I want to learn about space, is with food. But when the moon and Venus are changing phases, nobody's like biting off of them, right? They're still a sphere, like a ball. They're always going to be a ball. So the way the phases happen isn't because like part of it goes away, like the Oreo cookie thing. The phases happen because of the sunlight. Now I'm going to leave the sun, right, our sun, just off camera because that's a little bright. But if you notice with our moon here, or our Venus, depending on where I put it, I do have to have it lower. There we go. You can kind of see how it's really, really bright on the left side. I'm going to use my nose, okay? It's really, really bright right there. And that's because that's the side closest to our sun, right? And as we move this Venus or this moon around, do you see how that line, that kind of bright line, is kind of changing? How we kind of have a half moon there. And as we get behind, now the whole ball is lit up, right? And if we came around this other side, you would see that half. And as it goes closer to us, got a tiny, tiny crescent lit up. And then now the side that's lit up is behind the moon or Venus. So you can watch as this orbiting happens. You can see those phases change. I'm sorry, I could do this all night. This is so much fun. And I highly recommend y'all do this later. Parents, all you need is a sun without the lampshade on it is best. It's a little painful, but and a ball, and you can make your own phases. Highly recommend it. Very, very helpful in understanding all of that. I think, okay, so part of the reason that the phases happen because on Venus are because of where it is in its orbit in our solar system. Judy, do you want to tell us about our solar system?
Sure. I want to talk about the solar system, and the solar system is something that sometimes confuses people. So I would like to ask you now to type into the chat one thing that's in the solar system. And hopefully we'll come up with quite a variety of things because we have a lot of people typing into the chat. So type one thing that's in the solar system, and we'll talk about that in just a little bit. But the first thing I want to talk about is what's the difference between a planet and a star? Because we get to ask that a lot. And you know, we work at an observatory and we talk about stars and planets all the time. And I tend to get those words mixed up. So I might say star when I mean planet and vice versa. But there's a difference between a planet and a star. And so here is really, it's going to come here. A star. So this is a star. This is a picture of the sun. And this is a nice picture of the sun that came from the Big Bear Solar Observatory. And beautiful picture, right? A star is made of a huge number of atoms. And all those atoms give the star a lot of gravity. And all those that gravity pulls those atoms inward. And it pulls them so much that in the center of the star, atoms are smashing into each other and changing into new, heavier atoms. That's called nuclear fusion. Nuclear fusion gives off energy. So inside a star, we're making energy. That's why the star shines. Okay, let's add in a planet. You know this planet, right? This is a nice picture of Jupiter from the Hubble Space Telescope. Now, a big planet like Jupiter is made of really a lot of atoms, but not as much as a star. And so it doesn't have enough gravity to squeeze those atoms together enough to do nuclear fusion. So it's not bright like a star. So really, these are not the same size. I know I made them the same size. I made them exactly the same size. But here, let's just make them closer to about the right size. Really, the sun is a whole lot bigger than Jupiter. Jupiter is a whole lot smaller than the sun, and Jupiter is way bigger than the Earth. So in general, stars are bigger than planets. Stars give off a lot of energy. So I'm seeing a lot of answers about what's in the solar system. Hold on, I got a slide. This is a silly slide that is not a very good picture of the solar system, but I'm looking at the answers, and the answers say the sun, the Hubble telescope, the Kuiper belt, Pluto, asteroids, Uranus, the asteroid belt, dwarf planets, Saturn, Mars, Jupiter, Earth, me. Yes. And this picture is not to scale at all. It's kind of really badly out of scale, but it shows that the planets travel around the sun on orbital paths. Okay, so those are some of the things in the solar system. Now, I think what we're ready to do is show a live planet. Are we ready to show a live planet, Joe?
I think we're ready to show a live star.
That's what I meant. See, I said planet and I meant star because I get confused too. Yeah, we're gonna show live star next. Yay! All right. What is this star? This star is Vega. Vega is a nice bright star. It's still a little bit light outside here in West Texas. So this is a nice bright star called Vega. Can you see how bright it is? All I see is a dot. It's kind of shimmering a little bit. It's nice and bright for a few reasons. We can see it even though the sky is still a little bright because it's close by and because it's a little bigger than our sun. So that's Vega. That's pretty cool. Okay, what else are we gonna, let's see, we've seen the star and now we need to talk about more planets. So I think it's time for Martinique to tell us about planets.
Let me tell you about planets. So one thing that's going to happen here as we switch from our star to a planet is I'm going to show you all Joe. Joe is in charge of our telescope tonight. Joe, will you wave at us? We can hear you too.
Hold on a minute.
Say hi. All right. Joe is in charge of moving our telescope.
I was busy with something. Hello.
He's in charge of a lot of things right now. So you can see the telescope that we're using right behind him. That big black tube is the telescope we're using. On the bottom end of it is the camera that we're using tonight, our black and white camera to collect all the light from our stars. Now, Judy said that it's still pretty bright out, and you can kind of tell in this picture how bright the dome is above. And that's actually why we couldn't introduce Joe at the beginning of this, because he was as bright as the star itself. He was just whited out in there. And what Joe is going to do for us now is move the telescope. He has a few computer programs that he uses to get all of this done. One is for moving the telescope. We use SkyX, SkyX 10. And he tells it what he wants to point to next and presses slew. Slew is like the go button for moving telescopes. You can kind of hear it. Joe's going to make sure that all of those cords keep where they need to be so nothing gets tangled up. And Joe needs to move the dome. You all can see kind of that top little bit above that line kind of spinning around. That is because the telescope dome is a sphere, or a sphere. It's a circular shape, and the dome on top is kind of like a little half circle, and it can spin. And the dome on top has a window in it that astronomers call a dome slit. And that dome slit is like just a window with two doors that open so that we can see space. And if the telescope is not, in front, pointed at something, but not in front of the dome slit, it's just going to see the wall. So Joe has to move the dome slit in front of the telescope, which obviously you can't look out a window if you're staring at a wall. We already talked about that. So Joe is, okay, so then he sits back down, and now he's got to look at the camera. He's got to in the camera program that we're using, Sharpcap, he has to center the planet that we're looking at, so it'll be kind of the center of the image, and he has to adjust the exposure. So he has to tell the camera how much light to let in or not. If it's too bright, it'll be like way overexposed, and it'll be like, you know, like with when I was using my son before, and just everything's too bright and it hurts a little bit. And if it's too dim, well, then we won't see the things that we're hoping to see today. So once he has it centered and just enough light in there, we are going to look at a planet. And this planet is the largest in our solar system. Can anyone guess what that is? Joe, are you ready?
Yes. I'm ready.
All right, here we go. That is the first live planet that we're going to see tonight. There we go. Matilda, you got it. Jupiter. Jupiter is the largest planet in our solar system. Now, y'all have heard a lot about Jupiter, all right? Can you drop in the chat or tell a neighbor, someone you're sitting next to, maybe grandma, cat, someone? What is something you know about Jupiter? What's something that you know about it? I already told you it was the largest one. What's something else you know? Thank you, Joe. That looks fantastic. We're seeing great things there.
It's a little bit fuzzy because of the wind and the dust. It's not too dusty.
That's really something to note. It's really windy in West Texas today, and that wind picks up dust, and just wind moving the air around, and the dust kind of blocks light. All that stuff makes our scene not as great as we wanted it to be, maybe. Matilda says it's giant. It has a great red spot. Yes, it does. It's a gas giant. Yeah, y'all know a lot of cool things about Jupiter. Its revolution is 12 Earth years. Yes. So it takes Jupiter 12 years to orbit around the sun. 12 Earth years. It takes Earth only 1 year. Let's see. What else? What's something you noticed about Jupiter? What's something you're noticing about the view? You might have noticed already it's in black and white. That's our black and white camera for you, giving us some nice gray views. Someone likes this planet because of the storm. Yeah, one thing that we notice about Jupiter is that it has these stripes on it. And those stripes are from winds. Those are winds that, you know, are over 200 miles per hour blowing around the gases. And the different colors that you're seeing in those stripes in the wind is because of different temperatures and compositions. The dark areas, we call those the belts, and that is where air is sinking. And the lighter zones are called zones, and that's where some of that air is rising up. So those are just strong winds blowing air around on this big gas giant. Now, is anyone noticing we can't see the red spot right now? We can't see the red spot, and that's because just like the Earth, right? I'm gonna make myself big here. Just like, sorry, Judy, just like the Earth, Jupiter spins. So sometimes, you know, the front face is looking at it, and then sometimes, you know, you're looking at the back. So sometimes the red spot is facing us, and sometimes, well, it's not. And right now it's not. But I need to show it to you. So let me add my screen here in to show you a view. One thing I got to show you is that NASA has taken some amazing videos of the stripes on Jupiter. So these are those bands moving, that wind moving around. This is a few days of images just for looping for you. And you can see the different colors that you would see just about if you could use your naked eye to see those colors on Jupiter. This is what that would look like. And that red spot is just one big, huge storm. And that red spot is just a little bit bigger than the Earth. 1.2, 1.3 times the diameter of the Earth, and the winds in that storm are over 260 miles per hour. So real big storm going on. But like I said, unfortunately tonight, that is not something we're going to see with our view, just because it's on the other side. But there is something else I want to show you. And Matilda, you know exactly where we are going next. Joe, can I ask you to up the exposure? Let a lot of light in for us so we can see. Yeah. Matilda, you know exactly what we were going to see next. We were going to see the moons. Now, let me tell you about Jupiter's moons. Jupiter has 79 moons. We're only seeing 4 of them. These are the 4 Galilean moons. These are the moons that are big enough to reflect a lot of light back so that we can actually see them with our telescopes and our eyes. And we call them the Galilean moons because Galileo first observed these back in 1610. Now let me talk about the order they're in today. Let's see, the farthest one up on the left, right, top left there is going to be Europa. Europa is it's mostly water ice surface, and they think beneath that is some liquid water. So it's kind of a cool, interesting place, right? Liquid water, cool stuff happens in liquid water. It's the kind of place that we would maybe look for life, not like, humans walking around, but I don't know, little bacteria, little swimming algae, that sort of stuff. The one that's really, really close to Jupiter, that is called Io. Io is covered in volcanoes. Some of them are spewing lava miles high. That's an exciting place. And then on the other side, we're seeing Callisto, which is a rocky little moon. It's a little bit like our moon. It's heavily cratered, but icy. And then the next one is Ganymede. And Ganymede is the largest moon in our solar system. It's actually larger than the planet Mercury. And we're going to let Joe move our telescope here to our next object. I'm going to pull that picture off while I tell you about the next thing we get to look at. Somebody is screaming at the television. I'm so excited, y'all. This is fun. So the next planet that we are going to look at is a little bit smaller than Jupiter. The next planet takes about 29 years to go around the sun. Its day is only about 10 hours long. It spins pretty fast. Any guesses as to the next planet that we're going to be looking at? Give me all a second. You're probably shouting it at the television, don't you think, Lynn? Are they shouting it again? Yes, yes. I'm starting to see it. Here we go. Yep, our next planet is Saturn. Saturn is a beautiful planet, and the first picture that I'm going to show you is actually taken by the Hubble Space Telescope. The Hubble Space Telescope takes amazing images. Right? Judy talked about us getting good images because we're high up on a mountain. Well, the Hubble telescope is in space. It doesn't look through any air, so it gets amazingly clear images. It can collect a lot of light, get a lot of amazing pictures, great detail. Just awesome stuff. So I'm going to show you first an amazing picture of Saturn. And that's this. This is Saturn. It is a little bit like Jupiter in a few ways, right? It has stripes. Also winds that are spinning around, making those stripes for us. And actually the upper atmosphere winds have been clocked at over 1,000 miles per hour. So really windy there. I know we're complaining on the mountain today, but it's way windier there. And the rings, y'all, these rings never get old. Seeing the rings of Saturn is just amazing. Now, one thing I want to point out is the rings are really, really reflective. The reason they're so bright is because they're made up of, bits of dust, but also bits of ice. And ice is shiny. It, very reflective, reflects a lot of light back at us. And I've got a little video here of those rings spinning around. This video was taken, oh goodness, where was this video taken? I thought I had information here. Nope. Well, it was NASA, assuming the Cassini missions took these videos, and you can kind of see them spinning around a little bit there. Just absolutely gorgeous rings. Now, Saturn also has moons. It has 82 moons, so it's winning when it comes to moons. More moons than Saturn, or than Jupiter. But the best and coolest and most interesting moon around Saturn is Titan. And Titan is the second largest moon in our solar system, right? Just smaller than Ganymede. But Titan is really the only other place in our solar system that has a dense atmosphere like Earth, mostly made out of nitrogen. This is an interesting place in the solar system that astronomers want to go and learn about because there is rivers and lakes on the surface. They're methane rivers and lakes, so we're maybe not going to swim in them. But beneath that surface of rivers and lakes, there's some ice, water ice, and below that, there's an ocean of liquid water, they believe. So a very exciting place to be learning about. This is with that outer atmosphere in this picture. If you were to use an infrared camera, infrared light can well, it can kind of go through dust a little bit better than just visible light. So if you're using an infrared camera, you can see a little bit more of the features on Titan. So this is kind of what they're looking at when they're using an infrared camera. So very cool place, very interested in learning about that. But next, we're going to actually go see a live view. We're going to see a live view through our telescope. And I want you to think about a few things. How is this picture of our live view going to be different than this picture from the Hubble? It's going to be different in a few ways, right? The camera that we're using is black and white. Our telescope isn't in space, so it's going to be a wiggly picture, right? Do you think it's going to be bigger, smaller? What do you think? Let's have a look here. Let's have a look here. Yeah, Judy's saying smaller. I'm going to pull that up right here. There we go. Thank you, Joe. Oh my goodness, y'all. So this is our live view of Saturn. You know it's live because it's wiggling around. You can see that. That's our air. That's our air wiggling the light around. It's black and white, like we said. And I bet you if Joe did his magic, we might notice something. What do you think? Can you zap it, Joe? We are seeing a few moons there. That'll be Titan there in the lower left, that real bright one, and a few other moons there around Saturn. Other moons are like Rhea and Enceladus. Judy, can I ask you? Do you remember the other moons of Saturn? Titan, Enceladus.
Well,
Dione?
I don't remember all 82 of them. But yeah, Tethys, Dione, Rhea, Titan's the bright one.
Mm-hmm. Yes, so there are those moons of Saturn. Right, not all 82 of them, but a couple of them. All right, we're going to let Joe slew to our next object. While he's getting that ready, we have looked at Venus, Jupiter, and Saturn. All are planets in our solar system, orbiting around our sun, right? Our solar system orbiting our sun. But are those the only planets that exist in the entire universe, Judy?
Well, no. You all remember Vega. I want to talk about stars. I want to talk about planets that belong to other stars. So we started out by looking at Vega. And Vega is nice and close. It's about 25 light years away from us. And what that means is that the light we saw from Vega took about 25 years to get from there to here. That's close for stars. But since it's close, it means astronomers have studied it a lot. And one thing they've discovered is that, well, they're pretty sure Vega is pretty young. So the young age of Vega is about 455 million years young. And so since it's a young star, it has a bunch of stuff orbiting it, and it kind of looks like Saturn's rings. They call it a debris disk, and it's made of dust and rocks. And some astronomers said this stuff is going to form into planets. And some astronomers said maybe it formed into planets and they broke. And just this year, a group of astronomers published a paper showing some evidence that Vega has a planet. And that planet is different from anything in our solar system. Well, it's not different in one way. It's about the size of Neptune. So that's the same as something in our solar system, right? But this planet that's about the size of Neptune orbits Vega in about 2.5 days. 2.5 days means it's really close into Vega, and it's orbiting really fast. And nothing in our solar system, none of the planets go that fast in the solar system. So that's kind of crazy. And I think other astronomers probably disagree with this paper, but I think it's interesting that there are people who think there's evidence that there's a planet that orbits Vega. What I want to look at is I want to look at a star that is the very first star that was kind of like our sun, where astronomers found evidence of a planet orbiting that star. And that very first star was discovered, that evidence of the planet orbiting the star. The star had been known for a long time. The evidence that the planet was orbiting the star was discovered in 1995. So, you students who are watching this, you probably don't remember 1995, but I'll bet a lot of the parents do. 1995 is the first time that astronomers decided there was a planet orbiting a star that was more or less like our sun. And Joe, are we about ready to go there? Oh, yes, we are. Okay, so there it is. And the star is called 51 Pegasi, unless it's Vega again. It's 51 Pegasi, right, Joe? Awesome. Thank you. All right. 51 Pegasi means it is one of the stars and not one of the main stars, one of the stars in the constellation Pegasus. And it has a planet that is about half as big as Jupiter, but it's another weirdo. It orbits its star. You know how Jupiter orbits the sun in 12 years? 51 Pegasi b orbits 51 Pegasi in 4.5 days. So it's crazy different from anything in our solar system again, but it's the first one that was discovered orbiting a star that was like our sun. And the astronomers who discovered it did win the Nobel Prize kind of recently for that discovery. So I think that's very exciting. I also think it's kind of crazy that a star that's half the size of Jupiter goes around in 4.5 days. I hope you think that too. All right. So now I think it's time to answer questions. Is it time to answer questions?
I think now is when we want to
Yay!
pull all of your questions. I know that our
All right.
moderators have been answering a bunch as we've
Uh-huh.
gone, and they've stashed a few aside for us too. Lester Pennington is asking, are there any probes going to Venus in the future?
Why are you looking at me?
I'm not. So the probes that have gone to Venus have only lasted a couple of hours. Venus is very hot. It's a very tough environment to live in, to have anything survive in. So I think that the longest lasting probe was, goodness, I think it was a Russian probe, and it lasted like 2 hours, not even.
Yeah.
So I think going back there, I don't know. I don't know.
I'm sure people will send another probe to Venus.
At one point, yeah.
I don't know about them for sure. I want to answer this question from Svitha. And the question is, if the sun is undergoing nuclear fusion, then why isn't it blowing up? I love that question. So I said in the inside of the star, in the inside of the sun, nuclear fusion is happening. And that's where gravity is pushing atoms together. They're fusing together and forming a whole new element. And usually it's hydrogen fusing together to form helium. And the whole thing isn't blowing up because that does make pressure that pushes outward. But remember, the gravity is still pulling inward. So we like to say that the star is in what we call hydrostatic equilibrium. And I know those are really long words, but I love being able to say them because it makes me sound so smart to know big long words, right? Hydrostatic equilibrium means gravity pushing in balances energy pushing out. So the star doesn't explode because it's in balance. Okay. What's another question, Martinique?
Another question. Thomas says his 7th grader is wondering why there is a gap in the rings of Saturn.
Do you know? Oh, that's a beautiful picture.
It's called the Cassini division there. And I'm bad at explaining this because it's confusing to me. It's like,
yeah.
Go ahead.
Some of the gaps in the rings are there, and there are more gaps than just the Cassini division, but some of the smaller gaps are caused by little moons that actually the stuff that makes up the rings is little chunks, and the little moons just sort of move those little chunks out of the way. I don't know why the Cassini division is there, though. Sorry.
There's like there's resonant things with the gravitational stuff, and I can't explain that. Joe, you're welcome to join us if you have
If you
more
know
words
the
than we
answers.
do.
I can tell you that's a pretty good answer, but I can tell you those moons you're talking about that help cause the gap, they're called shepherd moons.
Oh,
They
shepherd
just-
moons. Thank you. We've shepherded
all I
away
know.
little bits. We've gathered the things up
Yeah.
to a little
Mhm.
flock that is now
Right.
a little moon.
Yeah.
Wonderful. Thanks,
So,
Joe.
so Richard Thielman says, why are planets and sun up when they are in the same plane? So, we showed a picture of the solar system, and it had the sun in the middle, and it showed the planets orbiting around the sun, and it looks like it should all be flat. So, why do we see them in the sky if they're in the same plane? Because that plane crosses our sky. So the sun, so maybe the sun is behind me, maybe I'm the Earth, maybe we can see Venus over here as the sun is setting, Venus is rising, and we see it in the sky. And there are other planets that are along that line across space. So we call that the line of the ecliptic. We also call it the plane of the ecliptic because the line shows us where the plane is. Oh, there you go. And we can see them in the daytime if we can see them. Most of the planets are too dim for us to see in the daytime, but once in a while, somebody will get a glimpse of Venus or Jupiter during the daylight. Freaks you out to see a star in the daylight with your eye. We've gotten calls from people saying, I saw something bright in the sky, and he told me where it was. It was Venus. So sometimes we can see planets in the daytime sky, and I think that's very cool.
Yeah, there's the plane that it would be on.
Yep.
Yeah.
Okay.
Lots of questions. Sorry,
more?
they're coming fast. Gonna try and pop them in. Oh, why has it been controversial redefining Pluto as a planet? That is a really wonderful question. So we all love Pluto. I think Pluto is like the underdog planet, right? It was like this little one that was found, like way later than all the other ones, and like we all loved Pluto. But Pluto at one point, Pluto didn't change. Pluto's the exact same. Pluto doesn't know that we changed. What we were finding is that with our better technology, our better telescopes, our better instruments and devices, we were finding more and more things that orbit our sun, like a planet, but were smaller than some of the planets, but maybe bigger than Pluto. But at one point, we just had to decide, do we want a list of 48 or 79 or 302 planets for our children to learn? Or do we learn so much that we have to define what that word planet means? And that's what we did. That's what happened, is that they decided that we need to redefine this word because we know so much more about it, about space and about what's out there. So they decided that a classical planet was massive enough to like crunch itself into a spherical shape because it has strong enough gravity to shape itself in a sphere. A classical planet also has cleared its orbit around the sun, so there's not a whole bunch of other rocks and stuff still kind of orbiting in that same area. Those are the two that I recall. And I think the reason that it was controversial is just people love Pluto so much, and we grew up with that. Change is hard. It's hard to redefine things. It just made a lot of people sad. I think that's all. But like I said, Pluto hasn't changed. And actually, I don't have the picture here, but Pluto has this amazing like little heart on it. If you Google picture of Pluto, you're gonna find it. Pluto loves us as much as we love him, and he's, in my mind, the king of the dwarf planets because we've just known him all along. So we don't have to feel sad. But yeah, it's rough on people. Is that the Pleiades on Judy's shirt? Yes, it is. Hashtag gift shop. I don't talk in hashtags.
Oh, you just did.
I did.
Why is Venus the second planet but the hottest? Zoe is asking. Here, I'll put that one up.
Oh, great question. So it's because of the atmosphere. Venus kind of has a runaway a global warming thing going on. A lot of energy coming in from the sun, and those clouds are trapping that carbon monoxide in, and it's warming and just kind of a runaway hot effect. Mercury is closer, but it doesn't have an atmosphere. There's no air to kind of hold air in, or hold heat in, rather. So the side that's facing the sun is hot, but the side that's facing away from the sun is like as cold as space. It is freezing. So it has nothing to hold that temperature in, whereas Venus has too much to hold too much temperatures in. Good question. Do the gas planets have a solid core?
We don't know.
They think?
We think Saturn does. We don't know about Jupiter.
Maybe.
Yeah.
I mean, it kind of makes sense. A lot of stuff, smushed together.
Oh.
Gravity pulled a bunch of stuff in. So makes sense that some of that stuff is a little more solid or pressured to the center to be solid.
And somebody else asked, would it be possible for a planet to eventually glow because of pressure and gravity? And that person was Bizdakni. And the answer is no, because that planet still doesn't have enough atoms to have enough gravity to make enough pressure to do nuclear fusion. So that's not going to happen.
Would it glow in the infrared?
Some planets make a little bit of energy and do glow a little in the infrared, but that doesn't make them stars.
And our eyes wouldn't see the glow. So I don't know if that counts.
Yeah.
I'm not glowing in infrared.
Noah wants to know if you think there used to be a planet between Mars and Jupiter.
Oh, and I'll bet that's because the asteroid belt is there. And the asteroid belt is made up of chunks of stuff. And so maybe that was a planet that broke up. I think astronomers are thinking right now that that's not the case. That maybe it's more likely to be stuff that just didn't form into a planet. Someone else asked earlier in the questions how far apart the asteroids are, and I don't know that answer, but I do know they're farther apart than in the movies. Joe, do you know the answer for how far apart the asteroids are in the asteroid belt?
Some of them, I guess they could be thousands of miles, or even, maybe thousands of miles away from each other. But like Judy said, and you see in the movies, like you see them zipping through the asteroid belt or something like in Star Wars.
It's not like that.
That's not
Bonk.
true. So, yeah, you're not going to bump into, yeah.
Looking through the question.
Somebody asked for the age of something like Venus. And we think the planets and the solar system are all about the same age, that the star, the sun, and the planets formed at about the same time, and they're all about 4.5 billion, is that right? Years old. I don't think any of the planets are older or younger.
I think they all formed around the same time.
Yeah.
Do you know how long it took those planets to form? From that cloud? Millions of years?
Hundreds of thousands to millions of years.
Okay.
Supernova knows. Thanks, Supernova.
Yeah. There we go.
All right, y'all. Any last questions here before we close up shop? Questions are our favorite. I just want to thank you all for adding so many to the chat here as we've gone through. We like to talk about what you're interested in, and we want to know what you're wondering about. So thank you so much for adding all those questions to the chat. Wow. Why can't Joe? Maybe this is a good one for you. Why can't you use a nuclear bomb to redirect an asteroid by causing it to eject pieces of itself? I don't know. That's like a movie thing, right? Where they're going to put, a bomb on one side and like the explosion will push it away that way. But yeah, then there will be smaller pieces that would, land on the planet, which in the movie would be Earth. It'd be very dramatic. There's actually, departments in governments that are making sure that we have means to move asteroids away from us if they move towards us. I don't know what their plans are.
Yeah.
I hope it involves calling Vince, that guy. What is his name? Never mind.
One of those movie guys.
Yeah, it was supposed to be an Armageddon joke, but I dropped it.
Okay.
I love having brain farts on the internet.
So Joe Michael Coronado asked, do orbits change? And for asteroids, yes, because asteroids are small. If they move past something that's more massive, the gravity of that more massive thing can perturb their orbit. For bigger planets, it takes more force to do that, and we don't see much change in those. Does the new Space Force interact with the observatory? Not that they've told us. I that's probably not the right way to answer that, but no, it doesn't.
And our mods are very helpful, and they told me that Bruce Willis. I don't know if that Bruce Willis will be part of the plan, but I hope so. All right. On that delightful note, we'd like to thank you all for joining us tonight and adding your wonderful questions, like I said. I do like to let you all know there's a few different ways that you can help support the observatory. You can always tune into our live streams and learn more. Interact with us on social media, follow us, subscribe, like, do all the fun things. There we go. We have public programs that have restarted in the last few months. We are doing guided tours and star parties. We always recommend you make reservations. We are selling out all the time. We do educational programs, so your students, your homeschool classrooms and beyond can interact with us doing virtual field trips. Also, on-site visits are starting again in February, and we will be doing teacher workshops again this summer. So always stay tuned to our Learn tab on the website to learn about those fun things. We thank our friends of the observatory for supporting the observatory in so many different ways. And you can find, fun, cool stuff in the gift shop always. So thank you everyone for joining us. We always have the question from families, how can I support my little astronomer who's so interested in this? And I'm going to leave you all with a few answers from the fabulous staff that work here. So thank you for joining us, and we hope to see you all again next time.